Hi guys, this is a way to look at the take-home test and go over stuff. So we have a solid dot, so we know that it's going to the right to infinity, so that's going to be a hard bracket, hard bracket from 3 to infinity. And then we're going to come down here. Let's take a look at this next one. This is going to start at -5. It goes to infinity as well. So I'm going to have a soft bracket at the -5. I don't know why this is jumping around. -5 to infinity. This one goes to negative infinity. So this is going to read it from left to right. Remember, this is on the left side. This is the right side, so left to right. So we're going to go from negative infinity to 6, hard bracket. Okay. Problem number 4, we have a bound region. So this is just going to go from -1 soft bracket to 4 hard bracket. Okay, and I have to erase these, unfortunately, because it's going to keep moving around on me. Number 5 is an OR problem, so that's going out to negative infinity. That's going to infinity. So we're going to go from negative infinity to -4, soft bracket, and then it's going to be a hard bracket from 7 to infinity. And that's all you have to do there. Now we're going to start graphing it. So it looks like I have an open dot on the 2, and it's going to shade to infinity. Number 5 is a solid dot on the 5, and it's going to shade to infinity. And this one is going to go from negative infinity to 0. Open dot on the 0 because I don't have a hard bracket. And then at the 6, it's going to be a solid dot, and that's going to infinity. Now we have to start solving this. Okay, I'm going to divide each side by -2. Remember, when I divide by a -2, the sign, the inequality sign, changes directions, and 14 over -2 is -7. So I'm going to have an open dot at 7, and that's going to infinity. When that takes place, we know that's going to negative infinity. So we'll read this from left to right. So I'm going to go from negative infinity, that's left, to -7, and the -7 has a soft bracket because we don't have the equal sign. Problem number 10, I'm going to subtract 8 from both sides because that's the opposite of positive 8. So that's going to get to 7. So this is going to have a solid dot at 7, and it's going to shade to the left to infinity. Okay, that's going to negative infinity. So negative infinity to 7, and it's a hard bracket on the 7 because I have a solid dot. I have the equal sign. Problem number 11, we need to start moving things back and forth. So it looks like I can subtract 3y from both sides first. If I do that, those cancel. That gives me y. And then I can actually add 2 to both sides. So keep the inequality sign the same. Something costs $6, you have $2 in your pocket, so you owe $4. So we have a solid dot at -4, and we're shading to infinity. Again, we're going to read this left to right. It's going to be hard bracket at -4 to infinity, and we're done. Problem number 12, we can do it. I can multiply everything by 4 first. That's going to cancel that out, so I get 1x, which is x, 4 times 1, which is 4, 2 times 4, which is 8. Then go ahead and solve it. Subtract 4 from both sides. So x is greater than 4. So I have an open dot on the 4, and it's going to infinity. So I have a soft bracket at 4 to infinity. The problem's done. Problem number 13. I would flip the whole thing over first because I want the x to be on the left side. I want the letter to be on the left side. So the sign is going to flip over as well, not because I multiplied or divided by a negative, because I flipped the whole problem over. Distribute. So 2 times 4x is 8x. 2 times negative 7 is negative 14. Add 14 to both sides. So 8x is greater than 24. Divide each side by 8. So that comes out to x is greater than 3. So I have an open dot at the 3, and we're going to go to the right to infinity. So that means I have soft bracket from 3 to infinity. Again, you're reading it from left to right. Problem number 14. So I'm going to highlight that for a minute. So what I'm going to do is I have to distribute that negative 3 over the parentheses. Do not go 5 minus 3. If you go 5 minus 3, you did it wrong. So negative 3 times x is negative 3x. Negative 3 times 6 is negative 18. It's greater than or equal to 5. These are like terms, so 5 subtract 18 is going to give me negative 13. And then add 13 to both sides. And that's going to give me negative 3x is greater than 18. Divide both sides by negative 3. Those cancel. I'm divided by a negative, so my sign has to flip directions. So I get to that. So open dot at negative 6. And that's going to negative infinity. Read it from left to right. So from negative infinity to negative 6, soft bracket. And it's done. Problem number 15. Trust me, my friends, break this into 2 problems. It'll make it easier. Make sure the middle goes with both problems. Okay? Then I would probably flip this one over because I want the x on the opposite side. So rather than less than, I'm going to go greater than. Add 8, add 8. So 2x is greater than 6. Divide by 2, divide by 2. X is greater than 3. Okay, so x is greater than 3. It's going to be an open dot on 3 and going this way. Change color. Change it to hot pink. This one I'm going to solve. I'm going to add 8 to both sides. So I get 2x is less than or equal to 20. Divide each side by 2. So x is less than or equal to 10. So 10, that's a solid dot at the 10. And it's going this way. This middle region here is our overlap. So if we read the overlap from left to right, soft bracket 3 to hard bracket 10. Done. Problem number 16, we're going to go ahead and solve this. So I get 6x is less than or equal to 3. Divide each side by 6. Reduce that. So we do have a fraction. We're going to try not to have fractions on the test, but on this is okay. So I have a solid dot here, and it's going to the left. So remember, this is an OR problem, so we don't have to worry about overlap. Then I'm going to go ahead and solve the other problem. Let's change that to a blue. So I'm going to add 18 to both sides. So I get 2x is greater than 24. Okay, because those cancel out. Divide each side by 2. And this one, unfortunately, we didn't double check it. So 12 is like over here, right? So I have an open dot going this way to infinity. This is going to negative infinity. So I have negative 8 to half, hard bracket. Because it was an OR problem, I want the word OR to be in there. And then I'm going to go with soft bracket 12 to infinity. Okay, let's take a look at these. So I'm going to graph that one first. It's already solved, so we just have to graph it. So I have an open dot, and it's going to go left. And then for the 2, I have a solid dot on the 2. And it's going this way. So this is my overlapped region. It's an AND problem because the word AND was there. So I'm going to list that region. So I'm going to go hard bracket 2 to 5, and the 5 is going to be a soft bracket because it was an open dot. Let's try this one. X is greater than 0. So this is going to go to the right. And then I'm going to change the color. For this one, I'm going to go solid dot on the 5. And I'm going to go this way. Now remember, this is OR. So I don't have to worry about overlap. Well, this graph exists both ways, so we're going to go from negative infinity to infinity, and it's all done. Problem number 19, this might have been on your front of that page, but mine moved. All right, so let's add 12, add 12. So I get 8x is less than 16, divide by 8, divide by 8. So x is less than 2. So I have an open dot of 2, and I'm going this way. This is an AND problem, so I'm worried about overlap. So minus 5, minus 5. X is greater than or equal to 5. So I have a solid dot on the 5, and it's going this way. If this was an OR problem, we can do it. We don't have overlap. It's AND. So there's no solution to this problem. It won't work. Okay, problem number 20 is an OR problem. I'm going to distribute 3 over the parentheses. Add 3 to both sides. And then divide each side by 3. So I have a 4 going to infinity. Remember, this one's an OR problem. I'm going to add 17. So something costs $13. I have $17 in my pocket, so I still have $4. Divide by 2, so x is less than or equal to 2. So that's going to go this way. So it is an OR problem. So it includes the original, all the original. So it's going to go from negative infinity all the way to 4, and the 4 is a soft bracket, because remember, OR does not have overlap. It doesn't have to have overlap, okay? And then let's take a look at this next one. Let's see. They went 5x plus 3x and got negative 2x. There's our mistake, okay? So we circle a mistake, and then we're going to rewrite the problem and rework it. So 5x and 3x is 8x plus 6 is greater than negative 20. Subtract 6 from both sides. So 8x is greater than negative 26. Divide each side by 8. Reduce the fraction where you can. So that's negative 13 over 4. So we could put it on a number line, but basically we are starting at negative 13 over 4, and our arrow is pointing to the right, so it's going to continue forever. So it goes to infinity. Now we're done. Okay, yes, you can get a fraction for an answer. It can happen. It looks like on this next problem, oh, okay, they distributed the negative 2 here, and they got the negative 8, I agree, but they distribute negative 2 to negative x. That should have been a positive. Okay, so let's write this. This is how it should have been done. So that's where the error took place, right there. Okay, then that's going to give me 2 plus 2x, because 10 minus 8 is 2. It's greater than 6. Subtract 2, subtract 2. 2x is greater than 4. Divide by 2, divide by 2. X is greater than 2. So I'm going to start at 2, soft bracket, because there's no equal sign, and it's going to go to infinity. Friends, if you could do all of that, make sure you ask questions. You can use this for the last 10 minutes on the test on Tuesday. Take care of one another. Bye-bye.